Number 4, draw the Lewis structure and use Vesper theory to predict the molecular geometry for the following molecules. Well, I see SO2, so I have a central sulfur, okay, and I have two oxygens bonded to that. Okay, that is the correct Lewis structure. Now, it is going to be bent. Now, I have this drawn in a line here, but what I need to be seeing is around my central atom, I have two bonded atoms, so that's AB2, but there is a lone pair of electrons. So if I go back to the table just until I get a feel for this, it's AB2, but with an electron pair. And so this electron pair that in this problem is around sulfur, here it's around 10, is actually driving these bonds down at an angle here, making the shape bent. What about B? And this is Ci4, by the way. It's not 4 chlorine atoms, it's Ci4. So I have a central carbon, 4 iodines around it. This one isn't very tough. Okay, don't have any double bonds, don't have any unshared pairs. And so I have an AB4, for example, it's a CH4. And we just have ourselves a tetrahedral. It's a 4-sided shape. On to C, boron trichloride, or sorry, should I say just boron chloride. We have a central boron and 3 chlorines around it. Okay, boron only having 3 valence electrons isn't going to bring a lone pair to the table. Okay, so there are no lone pairs here to adjust the angles at which these are bonding to the boron. And so they're simply going to spread out, right? There are 3 of them, so it's trigonal or trigonal, however you want to say it, 3. But there's no lone pairs to drive these bonds down at an angle. And so they remain in one plane. They remain flat. So we call it trigonal planar. Trigonal planar.